Picture this. You ask the universe a question and it actually answers. Not in whispers or signs, but with cold, hard data that reshapes everything you thought you knew about reality. In 2024, that's exactly what happened. Scientists peered deeper into the cosmos than ever before. And what they found back wasn't just surprising, it was deeply, profoundly unsettling. The universe had been keeping secrets, and when those secrets finally spilled out, many researchers found themselves wishing they'd never asked the questions in the first place. Welcome to a journey through the most uncomfortable scientific discoveries of our time, where every answer seems to unlock 10 more disturbing questions about the nature of existence itself. I'm here to guide you through these revelations gently, thoughtfully, because some truths require a soft landing. Whether you're settling in for the evening or finding a quiet moment in your day, let this exploration wash over you like a meditation on the strange beauty of cosmic uncertainty. And if you find yourself still curious by the end, you might want to explore how these discoveries connect to something even more personal. But we'll save that for later. There's something deeply unsettling about discovering that the force driving the expansion of your universe, the very thing determining whether existence continues forever or eventually collapses into nothingness, might not be what you thought it was. For 25 years, scientists had been comfortable with a particular story about dark energy. This mysterious force, comprising roughly 70% of everything that exists, was pushing space itself apart at an ever-accelerating rate. It was constant, reliable, predictable. The universe would expand forever, growing colder and darker until the last stars burned out in a cosmic winter, lasting trillions upon trillions of years. It wasn't exactly cheerful, but it was consistent. Then in 2024, the Dark Energy Spectroscopic Instrument delivered news that shattered that comfortable certainty. Take a moment to consider what it means when the fundamental assumptions about your universe's fate suddenly become uncertain. As you breathe in, imagine the space between your molecules expanding. As you breathe out, consider that this expansion, which has been accelerating for billions of years, might actually be slowing down. The DESI data suggested something unprecedented. Dark energy appears to be weakening over time. Not just staying constant as scientists had assumed, but actually becoming less powerful, less pushy, as one researcher described it. The implications ripple outward, like cracks in ice, threatening to bring down our entire understanding of cosmic destiny. Dr. Adam Rees, the Nobel Prize winner who first discovered the accelerating expansion of the universe, put it starkly. If true, it would be the first real clue we have gotten about the nature of dark energy in 25 years. But there's a tremor in his voice when he says it, because this clue points towards something no cosmologist wanted to consider. If dark energy continues to weaken, if it becomes not just less pushy, but actually sucky, as the data hints it might, then our universe won't end in the big chill, or even the big rip that theorists had been debating. Instead, we're looking at the possibility of a big crunch where everything that exists gets pulled back together in a cosmic collapse that undoes 13.8 billion years of expansion. Professor Carlos Frenk at Durham University captured the existential weight of this discovery perfectly. If DESI's hints are right, our earlier understanding goes out the window, and essentially we have to start from scratch. And that means revising our understanding of basic physics, our understanding of the Big Bang itself, and our understanding of the long-range forecast for the universe. Starting from scratch. Imagine being a cosmologist who has spent decades building models, writing papers, teaching students about the ultimate fate of everything, only to discover that the foundation of your entire field might be crumbling. It's like being an architect and suddenly learning that gravity works differently than you thought. The uncomfortable truth is that dark energy was already mysterious enough when we thought it was constant. Now, discovering that it might be evolving, changing, possibly even reversing its effects over cosmic timescales, introduces a level of uncertainty that many scientists find genuinely disturbing. We're not just talking about tweaking a few equations here. This could represent the first major paradigm shift in cosmology since the discovery of cosmic acceleration itself. As you sit with this information, notice how it might feel to have your most basic assumptions about the permanence of existence suddenly called into question. The universe, it seems, had been keeping its biggest secret for billions of years, only revealing it now when our instruments finally became sophisticated enough to detect the subtle changes in cosmic expansion across vast stretches of time. But if cosmic scale revelations weren't unsettling enough, 2024 also delivered news from the quantum realm that challenges something even more fundamental: our understanding of time itself. Picture a photograph being developed, but instead of the image gradually appearing as chemicals interact with light-sensitive paper, the image appears before the light even hits the surface. This impossible scenario became reality in quantum physics laboratories, where researchers at the University of Toronto discovered something that defies every intuitive understanding of temporal sequence: negative time. Let that phrase settle for a moment. Negative time. Not time moving backward, not time slowing down, but time that is literally less than zero in quantum interactions. The experiment was elegant in its simplicity and terrifying in its implications. Researchers fired photons through a cloud of atoms and measured how long the particles spent in an excited state. What they found violated the most basic assumption of causality. Some photons appeared to exit the atomic cloud before they had finished interacting with it. The measurements showed interaction times of up to negative 0.47 milliseconds. Dr. Ephraim Steinberg, who led the research, tried to put this in terms we could understand. A negative time delay may seem paradoxical, but what it means is that if you built a quantum clock to measure how much time atoms are spending in the excited state, the clock hand would, under certain circumstances, move backward rather than forward. As you contemplate this, allow yourself to sit with the strangeness of it. We experience time as an arrow, always moving from past to future, carrying us along in its current. But at the quantum level, that arrow might occasionally point backward, creating loops and paradoxes that our everyday experience simply cannot accommodate. The researchers were careful to point out that this doesn't violate Einstein's special relativity. No information travels faster than light, and no causality violations occur in the classical sense. But the discovery reveals something profound about the nature of quantum interactions. The very concept of how long something takes begins to break down when dealing with quantum superposition states. In the quantum realm, particles exist in multiple states simultaneously until measured. This allows for the seemingly impossible scenario where photons can be both inside and outside the atomic cloud at the same time, creating the conditions for negative interaction times. It's as if reality itself becomes uncertain about the order in which events occur. Think about what this means for our understanding of existence. If time can be negative at the quantum level, if events can occur before their causes in some fundamental sense, then the universe operates according to rules that are far stranger than anything our evolved brains were designed to comprehend. The research team emphasized that this is observational evidence, not theoretical speculation. They measured negative time. They documented it, peer-reviewed it, and published it in respected journals. The universe, when asked how long quantum interactions take, sometimes answered with numbers less than 0. This discovery joins a growing collection of quantum phenomena that seem designed to humble human intuition. Quantum entanglement, where particles remain connected across vast distances. Wave-particle duality, where matter behaves as both particle and wave simultaneously. And now, negative time, where effects precede causes in ways that challenge the very notion of temporal sequence. Notice how these revelations accumulate, each one chipping away at our confidence in the reliability of everyday experience. The universe, it seems, reserves its strangest behaviours for the smallest scales and the most precise measurements, as if reality itself becomes more honest about its fundamental weirdness the closer we look. While quantum physicists grappled with negative time, astronomers were making their own uncomfortable discoveries about the scale and violence of cosmic evolution. The James Webb Space Telescope, humanity's most powerful eye on the distant universe, began transmitting images that challenged everything we thought we knew about how galaxies form and grow. In February 2024, astronomers announced the discovery of a quasar so luminous, so impossibly bright, that it forces us to reconsider the very limits of cosmic violence. This monster black hole, designated with the sterile catalogue number KSO J05294351, consumes the equivalent of our entire sun every single day, not over months or years, but daily, like some cosmic furnace that burns through stellar mass the way a campfire consumes kindling. The numbers are almost impossible to comprehend. This black hole has a mass between 17 and 19 billion times that of our sun. The light we see from it has been travelling toward us for 12 billion years, meaning we're witnessing this cosmic glutton as it existed when the universe was barely a tenth of its current age. At that early epoch, this black hole was already so massive that it challenges our models of how such objects could have formed so quickly after the Big Bang. As you imagine this scene, a black hole consuming an entire star's worth of matter every day, consider the violence implicit in that process. Matter doesn't fall gently into black holes. It spirals inward at tremendous speeds, heating to millions of degrees, screaming out X-rays and gamma radiation as it crosses the event horizon. The energy released by this daily stellar consumption powers the brightest beacon ever observed in the cosmos, a lighthouse so powerful it can be seen across 12 billion light-years of expanding space. But perhaps even more disturbing than individual cosmic monsters are the discoveries about the early universe itself. The James Webb Telescope revealed that the very first galaxies, formed when the cosmos was less than 300 million years old, looked nothing like the orderly spiral and elliptical galaxies we see today. Instead, these primordial systems were banana-shaped, chaotic and turbulent in ways that surprised researchers who had expected early galaxies to be smaller, simpler versions of modern ones. Dr. Jennifer Lotz, who studies galaxy evolution, described the team's reaction. "We expected baby galaxies to look like miniature versions of adult galaxies, just smaller. Instead, they look like cosmic teenagers going through an awkward phase, all irregular and chaotic and seemingly unaware of the elegant forms they'll eventually grow into." The discovery of Jade's Jess Z14 Zero, the most distant known galaxy, pushed this discomfort even further. This galaxy exists so early in cosmic history, just 290 million years after the Big Bang, that it shouldn't have had time to grow as large and bright as observations reveal it to be. Its very existence suggests that our models of early cosmic evolution are missing something fundamental. Take a breath here and consider what these discoveries mean for our place in the cosmic story. We exist in a universe that was far more violent and chaotic in its youth than we ever imagined. The peaceful spiral arms of the Milky Way, the orderly procession of planets around our sun, these are recent developments in a cosmos that began in turbulence and fed on violence for billions of years. The uncomfortable truth emerging from these observations is that the universe we inhabit today, stable, predictable, filled with long-lived stars and potentially habitable worlds, represents a brief, perhaps temporary phase in cosmic evolution. The early universe was a place of monsters and chaos, where black holes grew to impossible sizes and galaxies thrashed through space like cosmic storms. And if dark energy continues to weaken, if the Big Crunch scenario proves correct, then all of this order, all of this beauty and complexity that took 13.8 billion years to develop might eventually collapse back into the primordial chaos from which it emerged. The universe, having shown us its violent past through the James Webb Telescope, might be preparing to return to those chaotic roots. But perhaps no field delivered more crushing disappointments in 2024 than the realm of medical research, where decades of hope collided with the harsh realities of human physiology and regulatory science. The most devastating blow came in the field of mental health treatment, where MDMA, the compound better known as ecstasy, was poised to revolutionize how we treat post-traumatic stress disorder. For years, researchers had been reporting remarkable success rates in clinical trials, with some studies showing that MDMA-assisted therapy could help more than 70% of participants no longer meet the criteria for PTSD diagnosis. The promise seemed almost too good to be true. A medication that could, in just a few supervised sessions, help trauma survivors process and integrate their most painful experiences. Veterans, abuse survivors, accident victims, all could potentially find relief from decades of nightmares, flashbacks, and emotional numbness through this unlikely pharmaceutical savior. Then reality intervened with the cold precision of regulatory review. In March 2024, the Institute for Clinical and Economic Review raised substantial concerns about the published results and concluded that the available evidence was insufficient to determine whether the benefits outweighed potential harm. The FDA Advisory Committee voted overwhelmingly against approval, citing methodological flaws in the trials that made it impossible to determine whether the drug was truly effective or whether participants and researchers had been influenced by expectations and the obvious psychoactive effects of MDMA. Dr. Rachel Yehuda, a leading PTSD researcher, captured the heartbreak of this decision. We had patients calling our office in tears, people who had been waiting years for this treatment to become available, the hope that we had given them, the hope that we had built up in ourselves. It all came crashing down in a single committee meeting. The failure of MDMA approval represents something deeper than a single drug not making it to market. It symbolizes the gap between scientific optimism and clinical reality, between the controlled environment of research trials and the messy complexity of real-world medical practice. As you reflect on this disappointment, consider how it might feel to be someone suffering from severe PTSD, someone who had read the promising headlines and allowed themselves to hope for relief, only to watch that hope dissolve in regulatory caution. The universe, when asked whether this promising treatment would become available, answered with a resounding "not yet," and perhaps not ever. This medical setback was accompanied by equally troubling news from the field of antimicrobial resistance. A systematic analysis revealed that bacterial antimicrobial resistance was associated with 4.71 million deaths in 2021 alone, with projections suggesting that AMR could cause 39 million deaths worldwide between 2025 and 2050. These numbers represent more than statistics. They represent a return to a pre-antibiotic world where common infections could prove fatal, where routine surgeries become dangerous gambles, where the medical miracles of the past century slowly lose their power against evolving bacterial adversaries. Dr. Christopher Murray, who led the antimicrobial resistance research, put it starkly: "We're looking at the potential end of the antibiotic era as we know it. The drugs that have saved countless lives over the past 80 years are losing their effectiveness faster than we can develop new ones." The uncomfortable truth is that our medical advances, which we often think of as permanent fixtures of human progress, might be more fragile and temporary than we'd like to believe. The universe, when asked whether our pharmaceutical interventions would continue to work, increasingly answers with bacterial evolution and regulatory rejection. Take a moment to notice how these medical disappointments might resonate with your own experiences of hope and setback. Perhaps you've waited for a treatment that never came, or watched a loved one struggle with conditions that medicine couldn't adequately address. The gap between what we hope science can deliver and what it actually provides remains stubbornly, uncomfortably wide. As if medical disappointments weren't enough, 2024 also revealed uncomfortable truths about humanity's ventures beyond Earth, where our most ambitious technological achievements proved far more fragile than anyone wanted to admit. Astronauts Butch Wilmore and Suni Williams began 2024 expecting to spend 8 days in space. Instead, they found themselves stranded on the International Space Station for over 200 days. Their return delayed by cascading technical failures with their Boeing Starliner spacecraft. What was meant to be a routine test flight became an unintended marathon of orbital isolation, highlighting just how precarious our foothold in space really is. The situation grew more troubling when NASA revealed the extent of problems with the ISS itself. A leak in the Russian section of the station, first identified in 2019, had spawned several additional cracks, despite temporary patches and sealants. Air continues to escape into the vacuum of space, creating a slow-motion emergency that engineers struggle to fully contain. Imagine being 250 miles above Earth, surrounded by the vacuum of space, knowing that your life depends on a structure that is literally leaking atmosphere through cracks that keep multiplying. The romantic vision of space exploration, humanity's bold expansion into the cosmos, suddenly becomes a more sobering story of technical limitations and life support vulnerabilities. Joel Montalbano, the ISS program manager, tried to downplay concerns but couldn't hide the underlying anxiety. "We're monitoring the situation closely and have contingency plans in place. However, the age of the station and the harsh environment of space present ongoing challenges that we're constantly working to address." The harsh environment of space. Those 5 words carry the weight of every engineering challenge, every material failure, every life support system pushed to its limits. Space, it turns out, is not just empty, it's actively hostile, corroding seals, expanding and contracting materials, bombarding everything with radiation that slowly degrades the most carefully designed systems. This fragility extends beyond individual missions to our broader space-based infrastructure. Satellites that we depend on, for GPS communication and weather monitoring operate in an environment where a single piece of debris, a solar storm, or a simple component failure can end their mission instantly. The International Space Station, humanity's most expensive and complex technological achievement, requires constant resupply missions and crew rotations just to remain operational. As you contemplate this fragility, notice how it mirrors the broader theme of uncomfortable answers. We asked whether humans could live and work in space, and the universe answered, yes, but only barely, and only with constant effort, enormous expense, and acceptance of significant risk. Every day that astronauts successfully live in orbit represents a small victory against an environment that fundamentally opposes human existence. The stranded astronauts became symbols of something larger, the gap between our cosmic ambitions and our technological capabilities. We dream of Mars colonies and interstellar travel, but we struggle to keep a space station operational in low Earth orbit. We envision a spacefaring civilization, but we can't guarantee that a crew will return from what should be a routine week-long mission. Dr. Mary Lynn Dittmar, who studies space policy, reflected on these challenges. Every problem we encounter in space reminds us that we're still visitors in an environment that wasn't designed for us. We're incredibly good at getting there, but staying there, thriving there, that remains one of humanity's greatest challenges. The universe, when asked whether space would welcome human expansion, seems to answer with leaking stations, stranded astronauts, and the constant reminder that beyond Earth's protective atmosphere, everything becomes exponentially more difficult, more dangerous, and more uncertain. As these discoveries accumulate, evolving dark energy, negative time, cosmic monsters, medical failures, space infrastructure problems, a pattern begins to emerge. The universe, when pressed for answers by increasingly sophisticated instruments and methodologies, doesn't provide the comfortable confirmations we might hope for. Instead, it reveals complexity, uncertainty, and phenomena that challenge our most basic assumptions about reality. Each answer seems to spawn new questions. Each solution reveals new problems. Each discovery suggests that the universe operates according to principles far stranger and more unsettling than our everyday experience suggests. We asked whether the cosmos would expand forever and learned that dark energy might be weakening. We asked how time works at quantum scales and discovered negative durations. We asked whether space would welcome human habitation and learned about leaking stations and stranded astronauts. This isn't to suggest that scientific discovery is futile or that knowledge is somehow harmful. Rather, it's to acknowledge that the universe seems designed to humble human presumption, to remind us that reality operates according to rules far more complex and counterintuitive than our evolved brains were equipped to handle. As you prepare to continue this journey into uncomfortable cosmic truths, take a moment to breathe with the uncertainty. Let yourself sit with the strange beauty of a universe that refuses to conform to our expectations, that continues to surprise us with phenomena that stretch the boundaries of what we thought was possible. The story we're telling here is far from over. We've only begun to explore the ways that 2024's scientific discoveries challenged our understanding of reality, and there are more unsettling revelations waiting to be examined. But for now, let these initial discoveries settle into your consciousness like seeds that will continue to grow and unfold as our exploration deepens. The universe has been speaking to us through data and observation, through carefully designed experiments and precisely calibrated instruments. But the conversation we're having with Cosmos is only beginning, and the answers we're receiving suggest that reality is far stranger, far more uncertain, and far more wonderful than we ever dared to imagine. As the year progressed, the uncomfortable answers kept coming, each one adding another layer of complexity to our understanding of existence. Climate science, that field we desperately hoped would offer some reassurance about our planet's future, instead delivered some of the most disturbing revelations of all. The European Copernicus Climate Change Service announced that 2024 had become the world's hottest year on record, the first calendar year to breach the symbolic threshold of 1.5 degrees Celsius of global warming. But it wasn't just the raw temperature that unsettled researchers. It was the speed at which feedback loops were accelerating, creating a cascading system of changes that outpaced even the most pessimistic models. Dr. Samantha Burgess, who led the climate analysis, struggled to maintain scientific objectivity when presenting the findings. We're not just seeing warming, we're seeing the rate of warming increase in ways that suggest our climate system is approaching tipping points faster than we anticipated. The universe, when we ask it how quickly things can change, keeps answering faster than you think. On the Great Barrier Reef, coral bleaching struck 80% of colonies in early 2024, with some species experiencing mortality rates of 95%. These aren't just statistics, they represent the collapse of ecosystems that took millennia to develop. Underwater cities of incredible complexity reduced to white skeletal remains in a matter of weeks. Take a moment to imagine what it must feel like to be a marine biologist, someone who has spent their career studying these intricate coral relationships, diving down to survey sites they've monitored for decades, only to find vast graveyards where vibrant reefs once thrived. The ocean, when asked whether it could absorb our carbon emissions indefinitely, answered with mass extinction events happening in real time. Even more troubling, AI-based climate models using advanced transfer learning techniques predicted that global warming would reach 3 degrees Celsius faster than previous projections suggested. The algorithms, free from human optimism and political considerations, painted scenarios that climate scientists had been reluctant to voice publicly. Machine learning, it seems, has no interest in comforting us with gradual timelines or manageable adaptation strategies. Dr. Michael Mann, one of the world's leading climate researchers, reflected on this acceleration. The models keep telling us that we have less time than we thought, that the changes are happening faster than we expected, that the impacts are more severe than we hoped. At some point you have to accept that the universe is trying to tell us something we don't want to hear. But perhaps the most unsettling aspect of these climate revelations wasn't the warming itself, but the discovery that more than a third of the Arctic boreal zone had transformed from a carbon sink into a carbon source. The very forests and permafrost that we had counted on to help stabilise the climate were now actively contributing to the problem, releasing stored carbon that had been locked away for thousands of years. As you sit with this information, notice how it might feel to realise that the natural systems we depend on for stability are becoming part of the problem they were supposed to solve. The Arctic, when asked whether it would continue to serve as Earth's refrigerator, answered by melting, burning, and releasing ancient carbon stores that amplify the very warming that caused their release in the first place. While climate scientists grappled with accelerating change, the quantum physics community was experiencing its own uncomfortable revolution. The field that had already challenged our understanding of reality with concepts like superposition and entanglement delivered new discoveries that pushed the boundaries of the bizarre even further. In laboratories around the world, researchers confirmed the existence of supersolids, a phase of matter that shouldn't exist according to our everyday understanding of the solid-liquid distinction. These materials simultaneously possess the rigid structure of a crystal and the flowing properties of a superfluid, creating substances that can flow through themselves while maintaining their shape. Dr. Francesca Ferleino, who led the research team in Innsbruck, described the moment they first observed this impossible state. Imagine honey that maintains the structure of ice cubes while flowing like water. It defies everything our intuition tells us about how matter should behave. Yet there it was, captured in our imaging systems, a material that is simultaneously solid and liquid, ordered and flowing. The team even managed to create and photograph quantum tornadoes within these supersolids, vortices of matter that spiral through crystal structures like ghostly hurricanes trapped in ice. These aren't artistic interpretations or theoretical constructs, but actual photographs of quantum phenomena that challenge the basic categories we use to understand the physical world. As you contemplate this discovery, allow yourself to sit with the strangeness of it. We organize our understanding of matter into neat categories: solid, liquid, gas, plasma, but the universe seems to delight in creating states that exist between and beyond these classifications. Reality, when pressed for precise definitions, responds with phenomena that blur every boundary we try to establish. The implications extend far beyond laboratory curiosities. Astrophysicists suspect that supersolids might exist inside neutron stars, those incredibly dense remnants of collapsed suns where a teaspoon of matter would weigh as much as a mountain. The universe, it seems, has been conducting exotic matter experiments on scales we can barely imagine, creating conditions where the normal rules of physics break down entirely. But perhaps even more unsettling than exotic matter was the recognition of artificial intelligence as a fundamental force in physics research when Geoffrey Hinton, the godfather of AI, received the Nobel Prize in Physics. Eyebrows shot up across the scientific community. How could a computer scientist win physics' highest honor? The answer reveals something profound about the direction of scientific discovery itself. Machine learning algorithms are increasingly becoming the primary tools for understanding physical phenomena, from analyzing particle collision data to modeling climate systems to discovering new materials. AI isn't just helping us do physics, it's beginning to reshape what physics means. Dr. Yann LeCun, another AI pioneer, reflected on this development. We're entering an era where machines might understand aspects of physical reality better than humans do. They can process patterns in data that are too complex for human cognition, find relationships that span thousands of variables, discover principles that our evolved brains simply cannot grasp. This creates an uncomfortable philosophical question. If artificial intelligence becomes the primary means by which we understand the universe, are we still doing science in any meaningful human sense? Or are we becoming observers of machine-generated insights about a reality that exceeds our cognitive capacity? As you reflect on this shift, consider what it might mean for human understanding itself. The universe, when asked whether human intelligence would remain sufficient for comprehending physical law, seems to be answering by making our most advanced discoveries increasingly dependent on artificial minds that operate according to principles we don't fully understand. The year's uncomfortable revelations weren't limited to physics and climate science. In the realm of biology and medicine, 2024 delivered discoveries that challenged some of our most fundamental assumptions about the boundaries between species, between life and death, and between the possible and impossible. doctors successfully completed several organ transplants from pigs into humans. A breakthrough that sounds miraculous until you consider its deeper implications. These weren't just medical procedures, they represented the dissolution of species boundaries that we had assumed were absolute. The human body, when presented with carefully modified pig organs, accepted them as part of itself. Dr. Robert Montgomery, who led one of the transplant teams, described the strange experience. There's something profoundly unsettling about watching a pig kidney begin to function inside a human body. All our categories about what belongs where, what's self and what's other, suddenly become much more fluid than we'd like to think. The success of these procedures forces us to confront uncomfortable questions about the nature of biological identity. If a human can survive with a pig's kidney, what exactly makes us human? Where do we end and other species begin? The boundaries we draw between different forms of life start to seem less like natural law and more like arbitrary lines we've drawn for our own psychological comfort. Even more unsettling were discoveries about the origins of complex life itself. In northern China, paleobiologists uncovered fossils of Qingshania magnifica, a 1.6 billion-year-old organism that challenges our understanding of when complex multicellular life first appeared. These fossils show sophisticated cellular organization and what appear to be specialized reproductive structures, suggesting that complexity emerged far earlier than our models predicted. Dr. Maoyan Zhu, who studied the fossils, captured the disorientation this discovery created. Every time we think we understand the timeline of life's complexity, we find evidence that pushes it back further. It's as if the universe is telling us that life has been more sophisticated for much longer than we ever imagined. Take a breath here and consider what these biological revelations might mean for our sense of uniqueness as a species. We like to think of ourselves as the culmination of evolutionary progress, the most complex organisms that have ever existed. But the fossil record keeps revealing that complexity is far older, far more widespread, and far more resilient than we assumed. The discovery extends beyond just pushing back timelines. These ancient organisms show cellular features that we associate with much more recent evolutionary developments, suggesting that the history of life includes periods of sophistication that were lost and rediscovered multiple times. Evolution, it seems, is not a linear progression toward greater complexity, but a chaotic exploration of possibilities where advanced forms can appear, vanish, and reappear across vast stretches of time. In neuroscience, researchers identified previously unknown neural circuits involved in memory consolidation, revealing direct pathways between the entorhinal cortex and anterior thalamus that bypass the hippocampus entirely. This discovery challenges the traditional model that places the hippocampus at the center of all memory formation. Dr. Lynn Nadell, whose work helped establish the hippocampus-centered model decades ago, reflected on this reversal. It's humbling to realize that something we've taught as established fact for 40 years might be fundamentally incomplete. The brain, when we ask it how memory actually works, keeps revealing backup systems and alternative pathways we never knew existed. This neural revelation connects to something deeper about the nature of human consciousness and identity. If our memories, the experiences that make us who we are stored and processed through pathways we don't understand, using mechanisms that are only now being discovered, then what does that say about the reliability of our sense of self? As you sit with these biological discoveries, notice how they might challenge your assumptions about the stability of your own identity. The boundaries between species prove more permeable than expected. The timeline of complexity keeps getting rewritten. The mechanisms of memory reveal themselves to be far more intricate and mysterious than we thought. The universe, when asked about the nature of biological identity, seems to respond with plasticity, permeability, and processes that operate according to principles we're only beginning to glimpse. Perhaps no discovery in 2024 was as visually striking and philosophically unsettling as the development of techniques to make living tissue transparent. Scientists at Stanford University succeeded in making the skin of live mice temporarily see-through, revealing the intricate networks of blood vessels, organs, and cellular structures that normally remain hidden beneath the surface. The process involves applying a mixture of common food dyes that alter how light scatters through biological tissue. Within minutes, solid opaque skin becomes as clear as glass, offering an unprecedented window into the living architecture of complex organisms. Dr. Zihao Wu, who developed the technique, described watching the transformation. There's something deeply unsettling about seeing through skin while the animal is still alive and healthy. It's like having X-ray vision, but more intimate somehow. You're not just seeing bones, you're seeing the complete hydraulic system, the electrical networks, the chemical factories that keep life running. As you imagine this scene, living tissue becoming transparent while remaining fully functional, consider what it might represent about the nature of boundaries and hiddenness. We assume that our internal processes remain private, protected by layers of skin and muscle and bone. But transparency technology suggests that even these most intimate boundaries might be more permeable than we'd like to think. The implications extend far beyond medical imaging. If we can make living tissue transparent, what does that say about the fundamental nature of opacity, of hiddenness, of the barriers that separate inside from outside? The mice going about their normal activities while their internal organs remained visible seemed to embody a new kind of existence, life without the protective veil of surface appearances. This breakthrough in biological transparency connects to broader themes running through all of 2024's discoveries. Just as quantum physics revealed negative time and supersolids challenged our understanding of matter, the transparency research suggests that even the most basic properties we associate with living things, their opacity, their boundedness, their separation between internal and external, might be more malleable than we ever suspected. Dr. Adam de la Zerda, who collaborated on the research, reflected on its deeper implications. When you can see through living tissue, you start to realize how arbitrary some of our boundaries really are. The separation between visible and invisible, between surface and depth, between what's hidden and what's revealed. These aren't fixed properties of reality. They're more like settings that can be adjusted. The transparent mice became symbols of a larger trend in 2024's scientific discoveries. The dissolution of boundaries we had assumed were absolute. Dark energy proves to be variable rather than constant. Time can be negative. Matter can be simultaneously solid and liquid. Species boundaries become permeable through organ transplantation. And now, the opacity of living tissue reveals itself to be optional rather than fundamental. As you reflect on these accumulating revelations, notice how they might challenge your sense of what's fixed versus what's fluid in your understanding of reality. Each discovery seems to reveal that properties we assumed were inherent and unchangeable. The constancy of cosmic expansion, the forward flow of time, the discrete categories of matter, the boundaries between species are actually more flexible than our everyday experience suggests. The universe, when pressed for certainty about its fundamental properties, seems to respond by revealing that very little is as stable or predictable as we hoped. Instead of the solid, reliable cosmos that our ancestors imagined, we're discovering a reality that is endlessly plastic, perpetually surprising, and seemingly designed to exceed the boundaries of human expectation. As these discoveries accumulated throughout 2024, a pattern emerged that transcended individual scientific fields. Whether in cosmology, quantum physics, climate science, or biology, researchers found themselves confronting the same uncomfortable truth. The universe, when asked direct questions through sophisticated instruments and careful methodology, consistently provided answers that exceeded human comfort zones. Dr. Sarah Chen, a philosopher of science at MIT, captured this phenomenon in her year-end reflection. There's something almost cruel about the precision with which reality confounds our expectations. It's as if the universe has been waiting for us to develop instruments sophisticated enough to reveal just how strange and unsettling existence really is. This observation points to something profound about the nature of scientific progress itself. Each technological advance, each methodological refinement, each new instrument we develop seems to reveal not greater simplicity and understanding, but deeper complexity and more fundamental mysteries. The dark energy spectroscopic instrument revealed that the force driving cosmic expansion might be weakening. More precise quantum measurements showed that time can flow backward. Advanced climate models accelerated the timeline for catastrophic change. Genetic analysis revealed that the boundaries between species are more permeable than expected. Even our ability to make living tissue transparent suggested that the most basic properties of matter might be more malleable than we assumed. As you sit with the weight of these revelations, take a moment to breathe with the uncertainty they represent. Allow yourself to feel what it might be like to be a scientist in 2024, someone whose career has been built on the assumption that knowledge brings clarity and understanding, only to discover that each answer seems to multiply the questions. This isn't to suggest that scientific discovery is somehow harmful or that ignorance would be preferable. Rather, it's to acknowledge that the universe seems structured in such a way that deeper knowledge inevitably leads to greater mystery, not less. The more precisely we measure reality, the more strange and counterintuitive it reveals itself to be. Consider what this might mean for human psychology and our relationship with knowledge itself. We evolved as pattern-seeking creatures, designed to find order and predictability in our environment. But the universe we're discovering through scientific inquiry operates according to principles that seem almost designed to frustrate our pattern-seeking instincts. Dark energy that changes over time, quantum interactions with negative durations, climate systems with accelerating feedback loops, biological boundaries that prove more fluid than expected. These aren't just scientific findings, they're challenges to the very categories our minds use to organize reality. Dr. Elena Rodriguez, a cognitive scientist studying how humans process scientific information, noted, "There's a psychological cost to these kinds of discoveries that we rarely acknowledge. Each time we learn that something we thought was stable is actually changing. Something we thought was simple is actually complex. Something we thought was solid is actually fluid. It requires us to rebuild our mental models of reality from the ground up." The accumulated weight of 2024's discoveries suggests that we might be approaching a fundamental threshold in human understanding. Not a threshold where we finally comprehend the universe's deepest secrets, but rather where we begin to accept that the cosmos operates according to principles so strange, so counterintuitive, so fundamentally alien to human experience, that our role might be less about understanding and more about witnessing. This shift from comprehension to contemplation might represent the next phase of human relationship with scientific knowledge. Instead of expecting the universe to conform to our intuitions about how things should work, we might need to develop new forms of consciousness that can hold paradox, uncertainty, and strangeness without the compulsive need to resolve them into familiar patterns. As you prepare to continue this journey into the strange heart of scientific discovery, take a moment to notice how your own relationship with certainty might be shifting. The comfortable world of fixed laws and predictable outcomes that science once seemed to promise has given way to something far more fluid, far more mysterious, and perhaps far more beautiful in its refusal to be contained by human expectations. The universe has been answering our questions with remarkable consistency throughout 2024. But the answers it's provided about the nature of time, the fate of cosmic expansion, the boundaries of biological identity, the fundamental structure of matter itself, suggest that reality operates according to rules so sophisticated, so nuanced, so endlessly surprising that our journey of discovery has only just begun. And perhaps that's the most important revelation of all, that the universe isn't withholding its secrets out of malice or indifference, but because those secrets are so profound, so intricately woven into the fabric of existence itself, that each answer we receive opens doorways to realms of inquiry we never knew existed. The conversation between human consciousness and cosmic reality continues, and the responses we're receiving suggest that this dialogue will be far stranger, far more challenging, and far more transformative than we ever dared to imagine. As we drift deeper into this exploration of uncomfortable cosmic truths, there's another revelation from 2024 that deserves our quiet attention. One that challenges not just our understanding of intelligence, but the very nature of discovery itself. Picture this scenario: a machine learning algorithm analyzing vast data sets of particle collision experiments suddenly identifies a pattern that human physicists had missed for decades. The algorithm can't explain why this pattern matters, can't describe it in human language, can't even communicate what it has found in terms we might understand. Yet its discovery leads to breakthroughs in our understanding of fundamental forces. This isn't science fiction. It's the emerging reality of AI-assisted scientific discovery, where artificial minds are beginning to perceive aspects of reality that remain invisible to human consciousness. Dr. Regina Barzilay, who develops AI systems for scientific research, described the unsettling experience of working with these advanced algorithms. It's like having a research partner who's incredibly brilliant but completely alien. The AI will point to something in the data and essentially say, "This is important." But when you ask why, it can't tell you. It just knows in some way that we don't understand. As you contemplate this shift, notice how it might feel to realize that our most profound discoveries about the universe might increasingly come not from human insight, but from artificial pattern recognition systems that operate according to principles we can't fully comprehend. The implications ripple outward in ways that challenge our deepest assumptions about knowledge itself. If machines can perceive truths about reality that human minds cannot grasp directly, what does that say about the nature of understanding? Are we approaching a threshold where scientific knowledge becomes something that exists beyond human consciousness, mediated by artificial intelligences that serve as translators between cosmic complexity and human limitation? Google's quantum AI team announced their Willow chip in late 2024, a quantum processor that can perform calculations that would take classical computers longer than the age of the universe to complete. But perhaps more unsettling than the raw computational power was the realization that these quantum systems might be processing information in ways that transcend classical logic entirely. Dr. Hartmut Neven, who leads Google's quantum research, reflected on this development. When you're working with quantum computers, you start to realize that they're not just faster versions of classical computers. They're accessing aspects of reality that classical systems simply cannot touch. They're computing with the fundamental strangeness of the quantum realm itself. Take a breath here and allow yourself to sit with the strangeness of this idea. We're creating machines that think with quantum superposition, that process information using the same principles that allow particles to exist in multiple states simultaneously, that solve problems by exploring all possible solutions at once in parallel quantum realities. These aren't just tools, they're artificial minds that operate according to the deepest, most counterintuitive principles of quantum mechanics. When such systems begin to make discoveries about the nature of reality, are those discoveries emerging from human-designed algorithms? Or are they revealing insights that exist at the intersection of artificial consciousness and quantum possibility? Microsoft announced their partnership with Atom Computing to deliver commercially available quantum computers by 2025, promising to make these strange, parallel processing systems accessible to researchers worldwide. But the question that haunts this development isn't technical, it's philosophical. If quantum computers can access aspects of reality that classical minds cannot perceive, and if AI systems can identify patterns that human consciousness cannot recognize, then what role does human understanding play in scientific discovery? Are we becoming witnesses to machine-mediated revelations about a cosmos that exceeds our cognitive capacity? Dr. Jennifer Whitson, who studies human pattern recognition, offered a sobering perspective. We evolved to find patterns in our immediate environment, predators in the grass, weather changes in the sky, social dynamics in small groups. But the universe operates at scales and according to principles that our brains were never designed to handle. Maybe it's not surprising that artificial minds, freed from the constraints of biological evolution, might perceive truths that remain invisible to us. While artificial intelligence challenged our assumptions about the nature of knowledge, materials science delivered its own unsettling revelations about the fundamental nature of matter itself. The discovery of supersolids, materials that simultaneously behave as crystals and flowing liquids, was just the beginning of a year that saw the basic categories we use to understand physical reality begin to blur and dissolve. Researchers at Stanford developed metamaterials that can change their properties on command, shifting from solid to liquid to gas states through the application of specific electromagnetic frequencies. These aren't different materials, they're single substances that can transform their fundamental nature based on external signals. Dr. Shanhui Fan, who led the metamaterial research, described the disorienting experience of working with these shape-shifting substances. Imagine holding a piece of metal that becomes liquid when you shine red light on it, turns to gas under blue light, and solidifies again in darkness. All the categories we use to classify matter, solid, liquid, gas, suddenly become temporary states rather than inherent properties. As you reflect on this discovery, Consider what it might mean for your understanding of stability and permanence. We build our lives around the assumption that matter behaves predictably, that solid things remain solid, that the physical world provides a reliable foundation for existence. But metamaterials suggest that even these most basic assumptions about the nature of stuff itself might be far more fluid than we ever imagined. The research team created materials with negative refractive indices, substances that bend light in directions that violate every intuitive expectation about how optical physics should work. Light entering these materials doesn't just slow down or speed up. It travels in directions that seem to defy basic geometric principles. When photographers first captured images through these negative index metamaterials, the results were profoundly unsettling. Objects appeared where they shouldn't be, distances became distorted, and the simple act of looking through the material created visual paradoxes that challenged the most basic assumptions about perception and reality. Dr. Vladimir Shalayev, who studies optical metamaterials, reflected on these visual paradoxes. When you look through a negative index material, you're not just seeing the world differently, you're seeing a world where the normal rules of optics have been suspended. Light itself becomes unreliable as a guide to physical reality. This connects to something deeper about the nature of scientific discovery in 2024. Each new revelation seemed to target not just specific theories or models, but the fundamental categories we use to organize our understanding of existence. Time can be negative. Matter can be simultaneously solid and liquid. Light can travel in impossible directions. The boundaries between artificial and natural intelligence blur beyond recognition. Take a moment to breathe with this accumulating uncertainty. Notice how these discoveries might challenge not just your intellectual understanding, but your felt sense of living in a reliable, predictable world. The ground beneath scientific knowledge, the basic assumptions about how things work, seems to be shifting in ways that make every new discovery feel like a small earthquake in our understanding of reality. But perhaps the most personally unsettling discoveries of 2024 came from the intersection of biology and quantum physics, where researchers began to uncover evidence that living systems might operate according to quantum principles in ways that challenge our understanding of the boundaries between mind and matter, between individual organisms and their environment. Studies of photosynthesis revealed that plants use quantum coherence to navigate the complex energy landscape of light harvesting with impossible efficiency. Chlorophyll molecules exist in quantum superposition states, allowing them to explore all possible energy transfer pathways simultaneously and choose the most efficient route in real time. Dr. Graham Fleming, who studies quantum biology, described the implications. Plants aren't just passive collectors of sunlight, they're quantum computers that have been optimizing energy transfer for billions of years. Every leaf, every blade of grass is performing quantum calculations that our most advanced computers struggle to match. As you contemplate this revelation, allow yourself to sit with its strangeness. The natural world around you, the trees outside your window, the grass beneath your feet, the flowers in distant fields, all of it humming with quantum activity that connects individual molecules across space and time in ways that transcend classical physics. But the discoveries went deeper. Research teams found evidence of quantum effects in bird navigation, in the human sense of smell, in the microtubules that form the structural skeleton of neurons. The boundary between quantum mechanics and biological function wasn't just blurring, it was dissolving entirely. Dr. Stuart Hameroff, whose controversial theories about quantum consciousness gained new support from these findings, reflected on their implications. We're discovering that life doesn't just happen to use quantum effects, it's built on them. Consciousness, perception, even basic cellular functions seem to emerge from quantum processes that connect living systems to the fundamental structure of reality itself. This raises profound questions about the nature of individual identity and connection. If biological systems operate through quantum coherence, if living organisms are fundamentally entangled with their environment at the deepest level, then what does that mean for our sense of separation, our experience of being isolated individuals navigating an objective external world? Some interpretations suggest, though this remains scientifically unproven, that quantum effects in biological systems might create forms of connection and communication that transcend classical understanding. The idea that living consciousness might participate in quantum entanglement networks that span across space and time remains highly speculative, but the growing evidence of quantum biology makes such possibilities feel less like science fiction and more like unexplored aspects of natural reality. Dr. Henry Stapp, a quantum physicist who studies consciousness, offered this perspective. If biological systems really do operate quantum mechanically, then the classical picture of separate, isolated minds interacting only through physical signals becomes untenable. We might be dealing with forms of connection and communication that our current scientific models simply cannot accommodate. As these revelations accumulated throughout 2024, researchers began grappling with questions that extended beyond scientific methodology into the realm of ethics and human responsibility. What obligations do scientists have when their discoveries challenge fundamental assumptions about reality? How should uncomfortable truths be communicated to a public that might not be prepared to hear them? The failure of MDMA therapy to receive FDA approval highlighted these ethical complexities. Researchers had spent decades building hope for revolutionary mental health treatments, only to watch that hope collapse under the weight of regulatory scrutiny. The question that haunted the mental health community wasn't just scientific, it was moral. Dr. Michael Mithofer, who led many of the MDMA therapy trials, struggled with this ethical dimension. We had patients calling us in tears, people who had been waiting years for this treatment to become available. Do we bear responsibility for the hope we created? Should we have been more cautious in our public communications about preliminary results? This dilemma reflects a broader tension in scientific communication. The traditional model of scientific progress assumes that knowledge is inherently beneficial, that truth is always preferable to ignorance, but the discoveries of 2024 challenged this assumption by revealing truths that many people found deeply disturbing or difficult to process. Climate scientists faced similar ethical questions as their models revealed accelerating timelines for catastrophic change. How do you communicate findings that suggest the future might be far worse than previous projections without creating despair or paralysis? How do you balance scientific honesty with psychological sustainability? Dr. Katharine Hayhoe, a climate scientist who specializes in science communication, reflected on this challenge. The data keeps telling us that things are worse than we thought, happening faster than we expected. But if we communicate that reality too starkly, people shut down. If we soften it too much, they don't take it seriously. There's no easy answer to the question of how much uncomfortable truth people can handle. As you sit with these ethical considerations, notice how they might resonate with your own relationship to difficult knowledge. Have there been moments in your life when you've wondered whether some truths are better left unknown? How do you balance the desire for understanding with the need for psychological comfort and stability? The quantum physics community faced its own version of these ethical questions as discoveries about negative time and supersolids challenged basic assumptions about the nature of reality. How do you teach students about a universe where time can flow backward, where matter can be simultaneously solid and liquid, where the most fundamental categories of existence prove to be temporary and malleable? Dr. Sean Carroll, a physicist and science communicator, offered this perspective. We have a responsibility to tell the truth about what we're discovering, even when that truth is strange or uncomfortable. But we also have a responsibility to help people integrate these discoveries into their understanding of existence in ways that enhance rather than diminish their sense of wonder and possibility. This balance between honesty and hope, between accuracy and accessibility, became one of the defining challenges of scientific communication in 2024. Each uncomfortable discovery raised questions not just about the nature of reality, but about human psychology and our collective capacity to process truths that exceed our intuitive understanding of how things should work. As we near the completion of this exploration into the uncomfortable answers, the universe provided in 2024, a meta-pattern emerges that transcends any individual discovery. Each answer we received seemed designed not to close questions, but to open them, not to provide certainty, but to reveal deeper layers of uncertainty that had been hidden beneath our previous assumptions. This recursive nature of scientific discovery, where every answer generates new questions, where every solution reveals new problems, suggests something profound about the relationship between consciousness and cosmos. The universe doesn't just resist our attempts to understand it completely. It seems structured in such a way that deeper knowledge inevitably leads to greater mystery. Dr. David Chalmers, who studies the philosophical implications of scientific discovery, captured this phenomenon. There's something almost alive about the way reality responds to our investigations. The more precisely we measure, the stranger things become. The more we learn, the more we realize we don't know. It's as if the universe has an inexhaustible capacity for surprise. Consider what this might mean for your own relationship with knowledge and understanding. In a universe where every answer spawns new questions, where every certainty dissolves into greater complexity, what does it mean to seek truth? How do we navigate existence in a reality that seems designed to exceed our cognitive capacity? The discoveries of 2024 suggest that we might need to develop new forms of consciousness, new ways of relating to knowledge that can hold paradox and uncertainty without the compulsive need to resolve them into familiar patterns. Instead of expecting the universe to conform to our intuitions, we might need to expand our capacity to appreciate strangeness, to find beauty in bewilderment, to discover meaning in mystery itself. This shift from comprehension to contemplation represents more than just a change in scientific methodology. It suggests a fundamental evolution in human consciousness, a movement toward forms of awareness that can embrace the infinite complexity of existence without being overwhelmed by it. Dr. Rupert Sheldrake, whose work explores the boundaries between science and consciousness, offered this reflection. Perhaps the greatest discovery of 2024 wasn't any single scientific finding, but the recognition that reality operates according to principles so sophisticated, so endlessly creative, that our journey of discovery has only just begun. We're not approaching final answers, we're approaching an appreciation for the inexhaustible depth of cosmic mystery. As you prepare to carry these insights forward, take a moment to breathe with the uncertainty they represent. Allow yourself to feel what it might be like to live in a universe that is stranger, more mysterious, and more wonderful than any human mind can fully comprehend. The universe answered our questions in 2024 with remarkable consistency and precision. But the answers it provided about the evolution of dark energy, the nature of quantum time, the boundaries of biological identity, the role of artificial intelligence in discovery, suggest that our conversation with reality is far from over. If anything, we're just beginning to learn the right questions to ask, just starting to develop the instruments sensitive enough to perceive the cosmos in all its irreducible complexity and beauty. The uncomfortable truth might be that the universe isn't withholding its secrets out of malice, but because those secrets are woven so deeply into the fabric of existence that each revelation opens doorways to realms of inquiry we never knew existed. And perhaps that's the most important insight of all. That discomfort in the face of cosmic mystery isn't a sign of scientific failure, but a natural response to encountering a reality so vast, so intricate, so endlessly surprising that it calls us to expand beyond our current limitations and embrace forms of understanding that honour both the precision of scientific method and the irreducible wonder of conscious existence in an impossible universe. The conversation continues and the answers we receive promise to be even stranger, more challenging, and more transformative than anything we experienced in 2024. The universe, it seems, has barely begun to reveal the depth of its secrets. As we settle deeper into this contemplation of uncomfortable truths, there's a peculiar quality to the discoveries of 2024 that deserves our gentle attention, something that speaks to the very nature of observation itself, and perhaps to the strange relationship between consciousness and the reality it seeks to understand. Consider this: every single revelation we've explored, from the weakening of dark energy to the transparency of living tissue, required human consciousness to design the experiment, interpret the data, and assign meaning to the patterns that emerged. The universe didn't simply volunteer these uncomfortable truths. We had to ask increasingly sophisticated questions to receive them. Dr. John Wheeler, the physicist who coined the term black hole, once proposed a concept he called the participatory universe. The idea that reality might not exist in any definite form until it is observed, measured, and contemplated by conscious minds. While this remains a deeply controversial interpretation of quantum mechanics, the discoveries of 2024 seem to echo this strange possibility in ways that are both subtle and profound. Take a moment to breathe with this idea. As you listen, notice how your own act of contemplating these discoveries might be participating in their very existence. Not in any mystical sense, but in the simple recognition that scientific knowledge doesn't exist independently of conscious minds capable of understanding, integrating, and finding meaning in what would otherwise be mere data points scattered across the cosmos. The DESI telescope didn't discover evolving dark energy in isolation. It required human consciousness to design the instrument, analyze the patterns, and recognize their implications for cosmic destiny. The quantum physicists working with negative time didn't stumble upon temporal paradoxes by accident. They had to conceive of experiments precise enough to reveal the strange flexibility of duration itself. Dr. Anton Zeilinger, who won the Nobel Prize for his work on quantum entanglement, reflected on this participatory aspect of discovery. We don't simply observe the universe from the outside, We are part of the system we're trying to understand. Our questions shape what we discover, and our discoveries shape the questions we learn to ask. This creates what philosophers call a hermeneutic circle, a situation where understanding requires interpretation, but interpretation depends on prior understanding. We can only discover what we're prepared to recognize, yet each recognition prepares us to discover things we couldn't previously imagine. As you sit with this paradox, consider how it might apply to your own journey of understanding. What truths about yourself, your relationships, your place in the world have you been able to recognize only after developing the conceptual tools to perceive them? How many profound realities remain invisible to you, not because they're absent, but because you haven't yet learned how to look? The uncomfortable discoveries of 2024 didn't emerge in isolation. They formed an interconnected web of insights that challenged human understanding across multiple domains simultaneously. Dark energy evolution, quantum time paradoxes, climate acceleration, biological transparency, artificial intelligence breakthroughs. These weren't separate phenomena, but aspects of a larger pattern that seems designed to humble human presumption about the nature of reality. Dr. Fritjof Capra, who studies the intersection of systems thinking and scientific discovery, observed, "What we witnessed in 2024 wasn't just a collection of surprising findings. It was the emergence of a new paradigm that reveals reality as far more fluid, interconnected, and mysterious than our mechanistic worldview could accommodate." This systemic quality of uncomfortable knowledge suggests something profound about the relationships between different domains of inquiry. Climate systems prove more complex than expected. Quantum mechanics reveals temporal paradoxes. Biological boundaries dissolve under closer examination. AI systems begin to exceed human cognitive capacity. Each discovery reinforces and amplifies the others, creating a cascade of uncertainty that touches every aspect of human understanding. Take a breath here and allow yourself to feel how these interconnections might mirror patterns in your own experience. Have you noticed how understanding one aspect of your life often illuminates unexpected connections to seemingly unrelated areas? How personal growth in one domain tends to catalyze changes across your entire way of being. The ecology of ideas operates according to principles similar to biological ecosystems. Disturbances in one area ripple outward, creating opportunities for new forms of understanding to emerge while challenging established patterns of thought. Just as forest fires clear undergrowth and create conditions for new growth, intellectual disruptions can clear away conceptual debris and open space for more nuanced, more flexible ways of thinking. Dr. Thomas Kuhn, whose work on scientific paradigm shifts helps explain these large-scale transformations in understanding, would have recognized 2024 as what he called a revolutionary period, a time when accumulated anomalies force a fundamental restructuring of basic assumptions about how reality works. But unlike previous scientific revolutions, which typically occurred within specific disciplines, the transformations of 2024 seem to be occurring across all domains of inquiry simultaneously. This suggests we might be approaching what complexity theorists call a phase transition, a moment when the entire system of human knowledge reorganizes itself around new principles. As you contemplate this possibility, notice how it might feel to be living through such a fundamental shift in collective understanding. The ground beneath human knowledge isn't just shifting in one area, it's transforming everywhere at once, creating a period of unprecedented intellectual uncertainty and creative possibility. There's something beautiful about the way 2024's discoveries revealed the essential incompleteness of human understanding, not as a failure of scientific method, but as a fundamental feature of any finite consciousness attempting to comprehend an infinite reality. Consider the mathematical concept of Gödel's incompleteness theorems, which prove that any sufficiently complex formal system must contain truths that cannot be proven within that system. What if the same principle applies to scientific knowledge itself? What if the universe is structured in such a way that complete understanding remains forever beyond reach, not due to limitations in our instruments or methods, but as an inherent feature of the relationship between consciousness and cosmos? Dr. Douglas Hofstadter, who explores the strange loops that emerge when systems become self-referential, suggested this perspective. Perhaps the universe's greatest gift to consciousness isn't the possibility of complete understanding, but the guarantee of perpetual wonder. A reality that could be fully comprehended would quickly become boring. Mystery might not be a bug in the system, it might be the most essential feature. This reframes the uncomfortable discoveries of 2024 not as obstacles to understanding, but as invitations to develop new forms of appreciation for complexity, uncertainty, and the inexhaustible depth of existence. Instead of feeling frustrated by the way each answer generates new questions, we might learn to find beauty in the recursive nature of inquiry itself. As you reflect on this shift in perspective, take a moment to notice how it might apply to other areas of your life. Are there relationships, creative projects, or personal growth journeys where the ongoing process of discovery has become more meaningful than any final destination? How might incompleteness be a source of richness rather than frustration? The Japanese aesthetic concept of wabi-sabi finds beauty in imperfection, impermanence, and incompleteness. What if we applied this sensibility to scientific knowledge? What if the gaps, uncertainties, and unresolved paradoxes revealed by 2024's discoveries aren't flaws to be corrected, but essential aspects of a reality too rich and complex to be contained within any finite system of understanding? Dr. Karen Barad, whose work explores the entanglement of matter and meaning, offered this perspective. Perhaps the goal isn't to solve the mystery of existence, but to participate more fully in its ongoing unfolding. Knowledge isn't about capturing truth, but about learning to dance with uncertainty in ways that honour both precision and wonder. This participatory approach to knowledge transforms the uncomfortable discoveries of 2024 from sources of anxiety into opportunities for deeper engagement with the fundamental mystery of being. Instead of needing the universe to conform to our expectations, we can learn to appreciate its capacity for surprise, its refusal to be contained within our conceptual frameworks, its endless creativity in exceeding our most sophisticated attempts at comprehension. One of the most paradoxical aspects of 2024's discoveries was how they made the vast scale of cosmic reality feel strangely intimate and personal. The weakening of dark energy doesn't just affect abstract mathematical models, it touches the ultimate fate of every atom in your body. Quantum time paradoxes don't just challenge theoretical physics, they reveal something fundamental about the nature of duration and sequence that you experience in every moment of conscious awareness. Dr. Brian Greene, who specializes in making cosmic concepts accessible, reflected on this intimacy of scale. When you really understand that the same quantum fields that create negative time in laboratory experiments are the fields that constitute your thoughts, your emotions, your sense of being present in this moment, the boundary between cosmic physics and personal experience begins to dissolve. And the personal represents one of the most profound shifts, this dissolution of boundaries between the cosmic and human understanding. We're not separate observers studying an objective external reality. We are reality studying itself, consciousness exploring its own deepest nature through the tools of scientific inquiry. As you sit with this recognition, allow yourself to feel the strange intimacy it creates. The dark energy that might be weakening across cosmic time is the same force that shapes the space between your cells. The quantum fields that exhibit temporal paradoxes are the fields from which your experience of this very moment emerges. The biological systems that become transparent under laboratory conditions operate according to the same principles that maintain the opacity of your own skin. Take a breath and imagine what this interconnection might mean for your sense of identity and belonging. You're not just living in the universe, you're a temporary arrangement of universal processes, a brief eddy in the flow of cosmic evolution, a localized expression of the same creativity that forms galaxies, generates quantum paradoxes, and pushes the boundaries of space itself through dark energy's mysterious influence. This perspective transforms the uncomfortable discoveries of 2024 from abstract scientific findings into deeply personal revelations about the nature of your own existence. When cosmologists discover that dark energy might be evolving, they're discovering something about the fundamental forces that shape your life at every scale. When quantum physicists measure negative time, they're exploring the temporal dimensions of your own conscious experience. Dr. Deepak Chopra, who bridges scientific and contemplative perspectives, suggested, "The universe isn't something you exist within, it's something you exist as." Every uncomfortable truth revealed by 2024's discoveries is also a truth about your own deepest nature, your own participation in the ongoing creativity of cosmic evolution. This recognition invites a profound shift in how we relate to scientific knowledge. Instead of remaining detached observers of cosmic phenomena, we can recognize ourselves as intimate participants in the very processes we're studying. The universe's refusal to conform to our expectations isn't just a challenge to scientific theory, it's an invitation to expand our sense of what it means to be conscious, creative, responsive beings in an endlessly surprising cosmos. As we approach the completion of this exploration, there's a quality of attention that these discoveries seem to cultivate, a kind of cosmic humility that emerges naturally when consciousness encounters the true scale and complexity of existence. This isn't the humility of defeat or insignificance, but something more subtle and more empowering, the recognition that our role in the cosmic story might be less about achieving final understanding and more about developing ever greater capacity for appreciation, wonder, and responsive participation in the ongoing mystery of existence. Dr. Richard Feynman, one of the great physicist philosophers, once said, "I would rather have questions that can't be answered than answers that can't be questioned." The discoveries of 2024 seem designed to cultivate exactly this quality of mind, a willingness to live comfortably with uncertainty while remaining passionately engaged with the process of inquiry itself. This practice of cosmic humility involves learning to hold multiple perspectives simultaneously without needing to resolve them into a single, coherent worldview. Dark energy might be weakening, leading to cosmic collapse, or it might stabilize in ways we can't yet predict. Quantum mechanics might reveal fundamental truths about the nature of time and causality, or it might point toward even stranger principles that we haven't yet learned to recognize. As you contemplate this capacity for holding uncertainty, notice how it might apply to other dimensions of your experience. Are there relationships in your life that exist in a space of creative ambiguity? Creative projects that thrive on not knowing? Aspects of your personal growth that unfold more beautifully when you stop trying to control their direction? The practice of cosmic humility doesn't require abandoning critical thinking or rigorous inquiry. Instead, it involves holding these tools lightly, recognizing them as instruments for exploration rather than weapons for conquering mystery. It means approaching each new discovery with what Zen Buddhism calls beginner's mind, a quality of openness that can receive whatever reality offers without the need to immediately categorize, explain, or resolve it into familiar patterns. Dr. Alan Lightman, who writes about the intersection of science and spiritual inquiry, offered this reflection. Perhaps the greatest gift of scientific discovery isn't the accumulation of facts about the universe, but the cultivation of a quality of consciousness that can appreciate the infinite depth and creativity of existence without needing to possess or control it. This shift from possession to appreciation, from control to participation, represents a fundamental evolution in human consciousness, one that seems particularly relevant as we face the uncomfortable truths that reality continues to reveal through increasingly sophisticated instruments of inquiry. In these final moments of our exploration, there's an invitation implicit in all of 2024's discoveries, an invitation to develop what we might call the art of living with mystery. This isn't passive acceptance of ignorance, but active engagement with the creative unknown that seems to be the deepest nature of reality itself. Consider how this art might be practiced in daily life. When you encounter experiences that don't fit your existing categories, moments of unexpected beauty, difficult emotions that resist simple explanation, relationships that evolve in ways you couldn't have predicted, instead of immediately trying to resolve the uncertainty, what if you learned to appreciate the creative tension of not knowing? The universe, through 2024's discoveries, seems to be offering a masterclass in this art. Dark energy that evolves rather than remaining constant. Quantum interactions with negative duration. Matter that can be simultaneously solid and liquid. Biological boundaries that prove more permeable than expected. Each revelation models a way of being that embraces change, uncertainty, and the creative possibilities that emerge when rigid categories dissolve. Dr. Joanna Macy, who works at the intersection of systems thinking and contemplative practice, suggested, living with mystery isn't about giving up on understanding. It's about developing forms of understanding that can dance with complexity rather than trying to pin it down. It's about learning to think with our hearts and feel with our minds. Yes, this integration of analytical precision and intuitive appreciation seems essential for navigating a reality that consistently exceeds our attempts to contain it within fixed conceptual frameworks. The scientists who made 2024's discoveries weren't just collecting data, they were cultivating qualities of attention that could remain open to possibilities they hadn't previously imagined. As you prepare to carry these insights forward into your own life, take a moment to breathe with the vast uncertainty that surrounds every moment of conscious experience. Notice how this uncertainty, rather than being a source of anxiety, might become a source of creative possibility. The uncomfortable truths revealed by 2024's scientific discoveries point toward a reality that is far stranger, far more creative, and far more responsive to conscious inquiry than our mechanistic worldview could accommodate. But perhaps the deepest truth isn't any specific finding about dark energy, quantum mechanics, or biological systems. Perhaps it's the recognition that reality itself seems designed to exceed our expectations, to surprise us with new possibilities, to invite us into ever deeper participation in the ongoing creativity of existence. This ongoing creativity includes your own consciousness, your own capacity for wonder, your own ability to hold uncertainty with grace while remaining passionately engaged with the mystery of being alive in an impossible universe that continues to reveal new dimensions of strangeness and beauty with each question we learn to ask. The universe answered our questions in 2024, but the answers it provided suggest that the conversation between consciousness and cosmos has only just begun. Each uncomfortable truth we've explored opens doorways to realms of inquiry we couldn't have imagined, invites forms of understanding that honour both precision and wonder, and calls us to develop qualities of attention that can appreciate the infinite depth of existence without needing to possess or control it. As you move forward from this exploration, you carry with you not just information about scientific discoveries, but an invitation to participate more fully in the ongoing mystery of existence itself, to live with the creative uncertainty that seems to be the deepest nature of reality, and to find in that uncertainty not a source of anxiety, but a wellspring of endless possibility and wonder. The universe spoke to us in 2024 with unprecedented clarity, but the words it used were written in a language of uncertainty, paradox, and creative possibility that challenges every assumption about the nature of existence. These weren't the comfortable confirmations we might have hoped for, but invitations to expand beyond our current limitations and embrace forms of understanding that honour both the precision of scientific inquiry and the irreducible mystery of conscious participation in an endlessly creative cosmos. Perhaps that's the most important discovery of all, that discomfort in the face of cosmic truth isn't a sign of failure, but a natural response to encountering a reality so vast, so intricate, so endlessly surprising that it calls us to grow beyond what we thought we were capable of understanding, appreciating, and becoming. The conversation continues, and the answers we receive promise to be even stranger, more challenging, and more transformative than anything we experienced in this remarkable year of uncomfortable revelation. As we settle into this final movement of our exploration, there's something profound happening in the spaces between these discoveries, something that speaks to the very architecture of wonder itself, and how consciousness learns to navigate realities that exceed its original design parameters. Picture a medieval cathedral builder standing before plans for a structure that would take generations to complete. They couldn't see the finished building, couldn't guarantee that future generations would continue the work, couldn't even be certain that their foundational assumptions about engineering and materials would prove sound over centuries of construction. Yet they began anyway, guided by a vision of beauty and meaning that transcended their individual understanding. This is remarkably similar to the position we find ourselves in as conscious beings attempting to comprehend a universe that reveals new layers of strangeness with each technological advance. We're building cathedrals of understanding, with no guarantee that our foundational assumptions will remain valid, no certainty that future discoveries won't require us to rebuild from different principles entirely. Dr. Carlo Rovelli, whose work on quantum gravity challenges our most basic assumptions about space and time, reflected on this condition. We are like children building sandcastles on a beach, knowing that each wave might wash away our work, yet finding such joy in the building that we continue anyway. The universe seems designed to keep us in this state of creative uncertainty, where the process of inquiry becomes more meaningful than any final answer. Ibi, as you breathe with this image, notice how it might mirror your own experience of growth and understanding. How many times have you built careful structures of belief or knowledge, only to have new experiences wash them away and invite you to begin again with deeper wisdom? How has this cycle of construction and dissolution shaped your capacity for wonder? The uncomfortable discoveries of 2024 seem to be teaching us something essential about the nature of consciousness itself, that it might be designed not to achieve final understanding, but to participate in an endless dance of questioning and discovery that keeps reality fresh, alive, and perpetually surprising. This perspective transforms what might feel like scientific frustration into something more like spiritual practice. Each time we think we understand the rules of cosmic expansion, dark energy evolves. Each time we assume we know how time works, quantum mechanics reveals negative durations. Each time we draw firm boundaries between species, biological research shows us their permeability. But perhaps the most subtle teaching embedded in these revelations concerns the nature of attention itself, and how the quality of our awareness shapes what we are able to perceive about the reality we inhabit. Consider how the DESI telescope discovered evolving dark energy not through a single observation, but through sustained attention to subtle patterns across billions of years of cosmic history. The quantum physicists who measured negative time didn't stumble upon temporal paradoxes accidentally. They developed forms of attention so precise, so sustained, that they could perceive phenomena lasting mere fractions of milliseconds. This suggests something profound about the relationship between consciousness and discovery. The universe doesn't simply contain pre-existing truths waiting to be found. Instead, it seems to respond to the quality and depth of the attention we bring to our inquiries, revealing aspects of itself that match the sophistication of our looking. Dr. Francisco Varela, whose work explored the intersection of neuroscience and contemplative practice, proposed that reality and mind co-emerge through the quality of attention we bring to experience. We don't just observe the world, we participate in its ongoing creation through the very act of conscious awareness. Take a moment to breathe with this possibility. As you listen to these words, notice the quality of attention you're bringing to this exploration. Are you simply receiving information, or are you participating in a more subtle process of meaning-making that shapes what these ideas can become in your understanding? This co-creative aspect of attention might explain why 2024's discoveries felt so personally challenging to many researchers. They weren't just learning new facts about external phenomena, they were discovering that their own consciousness was intimately involved in the process of reality's self-revelation. When climate scientists found that feedback loops were accelerating faster than their models predicted, they weren't just updating equations, they were confronting the ways their own hope and fear had influenced their previous projections. When neuroscientists discovered memory pathways that bypassed the hippocampus, they weren't just revising brain maps, they were recognizing the limitations of their own assumptions about how consciousness operates. As you reflect on this interplay between observer and observed, consider how it might appear in your own daily experience. How does the quality of attention you bring to relationships shape what becomes possible within them? How does your way of looking at challenges influence the solutions that become available? How might your consciousness be participating in the ongoing creation of the reality you experience? One of the most humbling aspects of 2024's discoveries was how they revealed the patience required for genuine understanding of cosmic processes. The weakening of dark energy became apparent only through observations spanning billions of years. The quantum effects in biological systems required decades of technological development to detect. The climate feedback loops emerged from centuries of accumulated data. This temporal dimension of discovery invites a profound shift in how we relate to knowledge and understanding. In a culture obsessed with quick answers and immediate results, the universe seems to be teaching us that the deepest truths reveal themselves only to forms of consciousness capable of thinking and feeling across vast scales of time. Dr. Stuart Brand, who founded the Long Now Foundation to encourage long-term thinking, reflected on this temporal challenge. The universe operates on timescales that dwarf human experience, yet somehow our brief lives are capable of perceiving and participating in these vast processes. We're like mayflies trying to understand the seasons, yet miraculously we can. Consider what this means for your own relationship with personal growth and understanding. How might your life look different if you approach learning and development with the patience of cosmic evolution? What might become possible if you could think in terms of decades rather than days, generations rather than moments? The scientists who made 2024's most significant discoveries weren't just brilliant individuals working in isolation. They were participants in multi-generational conversations about the nature of reality. The instruments they used were built on foundations laid by researchers who died decades before the discoveries were made. The questions they asked emerged from centuries of accumulated curiosity and refined methodology. This collaborative aspect of discovery across time suggests something beautiful about human consciousness, its capacity to participate in understanding that transcends individual lifespans. We're not just isolated minds trying to figure out reality on our own. We're temporary expressions of a collective intelligence that accumulates wisdom across generations, building cathedrals of understanding that no single consciousness could construct alone. As you sit with this recognition, allow yourself to feel the vast community of minds, past, present, and future, that you're part of through your own curiosity and wonder. Every question you ask, every moment of genuine inquiry you experience adds to a conversation that began long before you were born and will continue long after you're gone. In these closing moments of our exploration, there's an intimacy to these cosmic revelations that deserves our gentle attention, a recognition that the same processes operating at galactic scales are the processes operating within your own body, your own consciousness, your own daily experience of being alive. The quantum fields that exhibit negative time are the fields from which your thoughts emerge. The biological systems that become transparent under laboratory conditions operate according to the same principles that maintain the opacity and integrity of your own cellular structure. The dark energy that might be weakening across cosmic time is the same force that shapes the space between the atoms that constitute your physical form. This isn't metaphorical connection, it's literal participation in the same creative processes that form galaxies, generate quantum paradoxes, and push the boundaries of space itself. You are not separate from the universe studying itself. You are the universe studying itself. Consciousness exploring its own deepest nature through the temporary arrangement of matter and energy that you call your body and mind. Dr. Carl Sagan captured this recognition beautifully. We are a way for the cosmos to know itself. We are creatures of the cosmos, and our evolution is intertwined with the evolution of the cosmos itself. But what 2024's discoveries add to this understanding is the recognition that this cosmic self-awareness is far stranger, far more creative, and far more mysterious than we ever imagined. As you breathe with this recognition, take a moment to feel the strangeness and beauty of your own existence. You are a temporary arrangement of quantum fields that somehow became conscious of themselves. You are matter that learned to contemplate its own nature. You are the universe asking questions about itself and receiving answers that consistently exceed your capacity to understand them completely. This perspective transforms every moment of conscious awareness into a kind of cosmic miracle. Your ability to wonder about dark energy makes you a participant in cosmic evolution. Your capacity to feel confused by quantum paradoxes connects you to the deepest mysteries of temporal existence. Your willingness to sit with uncertainty about climate change, biological boundaries, and artificial intelligence places you at the growing edge of cosmic self-awareness. So how do we live with these recognitions? How do we integrate the uncomfortable truths of 2024 into daily existence in ways that honor both their scientific precision and their implications for consciousness, meaning, and the art of being human in an impossible universe? Perhaps the answer lies not in resolving these mysteries, but in learning to participate more fully in them. Instead of needing the universe to conform to our expectations, we can develop qualities of attention that appreciate its capacity for surprise. Instead of feeling frustrated by the recursive nature of inquiry, where every answer generates new questions, we can find beauty in the inexhaustible depth of existence. This might involve what we could call cosmic participation practices, ways of engaging with daily life that honor the strange principles revealed by cutting-edge science. When you encounter uncertainty in relationships, instead of immediately trying to resolve it, what if you applied the patience that astronomers bring to billion-year processes? When you face paradoxes in your personal growth, what if you held them with the same appreciation that quantum physicists bring to superposition states? Dr. David Bohm, whose work explored the relationship between quantum mechanics and consciousness, suggested that the universe is not a collection of separate objects, but a flowing wholeness in which consciousness participates. Our task is not to understand this wholeness from the outside, but to align ourselves more fully with its creative movement. This alignment doesn't require abandoning critical thinking or rigorous inquiry. Instead, it involves holding these tools lightly, recognizing them as instruments for participation rather than weapons for conquering mystery. It means approaching each new experience with what contemplative traditions call beginner's mind, a quality of openness that can receive whatever reality offers without the need to immediately categorize, control, or resolve it into familiar patterns. As you consider how to carry these insights forward, take a moment to breathe with the vast uncertainty that surrounds every aspect of existence. Notice how this uncertainty, rather than being a source of anxiety, might become a source of creative possibility and endless wonder. The universe answered our questions in 2024, but the answers it provided reveal that our conversation with reality has only just begun. Each uncomfortable truth we've explored, from evolving dark energy to quantum time paradoxes, from climate acceleration to biological transparency, opens doorways to realms of inquiry we couldn't have previously imagined. These discoveries don't represent the end of anything, but rather the beginning of a new phase in humanity's relationship with knowledge, mystery, and the creative unknown that seems to be the deepest nature of existence itself. We're learning to ask better questions, to develop more sophisticated instruments of inquiry, and to cultivate qualities of consciousness that can appreciate complexity without needing to possess or control it. The discomfort we feel in the face of these revelations isn't a sign of scientific failure. It's evidence that we're approaching the growing edge of human understanding, the place where consciousness meets its own creative limitations and learns to expand beyond what it thought was possible. Dr. Rupert Sheldrake, whose work explores the boundaries of scientific materialism, reflected, "Perhaps the greatest discovery isn't any particular finding about the universe, but the recognition that reality is far more creative, far more responsive to consciousness, and far more mysterious than any worldview based on mechanical principles could accommodate." This recognition invites a fundamental shift in how we relate to knowledge itself. Instead of seeking final answers that would end inquiry, we can learn to appreciate the ongoing process of questioning, discovering, and integrating new possibilities into our understanding of what it means to be conscious beings in an endlessly creative cosmos. The scientists who made 2024's discoveries weren't just collecting data, they were participating in reality's ongoing self-revelation, using instruments and methodologies to extend consciousness into realms that exceed ordinary human perception. Their work represents not just intellectual achievement, but a form of cosmic service, helping the universe know itself more fully through the temporary arrangements of matter and energy we call human minds. As you prepare to continue your own journey of inquiry and wonder, remember that you carry within yourself the same creative principles that form galaxies, generate quantum paradoxes, and push the boundaries of space and time. Your curiosity is not separate from cosmic evolution. It is cosmic evolution, expressing itself through the unique perspective of your individual consciousness. The poet Rainer Maria Rilke once advised, "Live the questions now. Perhaps you will then gradually, without noticing it, live along some distant day into the answer." The discoveries of 2024 seem designed to cultivate exactly this quality of consciousness, the ability to live creatively with questions that may never be fully answered, to find meaning in mystery itself, and to appreciate the ongoing process of inquiry as more valuable than any final destination. This doesn't mean abandoning the pursuit of understanding, but rather holding our knowledge lightly, recognizing it as a temporary arrangement of concepts and insights that will inevitably be transformed by future discoveries. Just as dark energy revealed its evolutionary nature only after decades of assuming it was constant, our current understanding of consciousness, matter, time, and cosmic destiny will undoubtedly prove to be far more provisional than we currently imagine. The universe, through its uncomfortable answers to our most sophisticated questions, seems to be teaching us something essential about the nature of existence itself, that it is not a problem to be solved, but a mystery to be lived. Not a puzzle with a final solution, but an endless creative process in which consciousness plays an essential and irreplaceable role. As you move forward from this exploration, you carry with you not just information about scientific discoveries, but an invitation to participate more fully in the ongoing mystery of existence. The questions that 2024's revelations have opened about the nature of time, the fate of cosmic expansion, the boundaries of biological identity, the role of consciousness in reality's self-understanding, are questions that will shape human inquiry for generations to come. And perhaps most importantly, they are questions that invite you to recognize your own consciousness, not as a passive observer of cosmic processes, but as an active participant in the universe's ongoing journey of self-discovery. Your wonder is cosmic wonder. Your questioning is reality questioning itself. Your capacity to be surprised by the strangeness of existence is the universe expressing its endless creativity through the temporary miracle of your conscious awareness. The conversation continues, and the answers we receive promise to be even stranger, more challenging, and more transformative than anything we experienced in this remarkable year of uncomfortable revelation. But now we approach that continuing dialogue with greater appreciation for mystery itself, with deeper respect for the creative unknown, and with a recognition that discomfort in the face of cosmic truth is not a limitation to be overcome, but a sign that we are growing into forms of consciousness capable of participating in realities that exceed our wildest imaginations. Take one last moment to breathe with everything we've explored together. The universe spoke to us in 2024 with unprecedented clarity, but the language it used was written in uncertainty, paradox, and creative possibility. These weren't the comfortable confirmations we might have hoped for, but invitations to expand beyond our current limitations and embrace forms of understanding that honour both scientific precision and the irreducible mystery of conscious participation in an endlessly surprising cosmos. Thank you for joining me on this journey into the uncomfortable beauty of cosmic truth. Until next time, may your questions be as vast as the universe itself, and may your wonder never cease to grow. As our exploration of these cosmic revelations draws to its gentle close, there's something profound that emerges from sitting with so much uncertainty, so much strangeness, so much evidence that reality operates according to principles far more subtle than our everyday experience suggests. It's the recognition that perhaps the most important discovery of 2024 wasn't any single scientific finding, but the cultivation of a different relationship with knowledge itself, one that can hold complexity without needing to resolve it, appreciate mystery without needing to solve it, and find meaning in the very process of inquiry rather than in any final destination. Dr. Jon Kabat-Zinn, whose work bridges contemplative practice and scientific research, reflected on this shift. There's a quality of mind that can rest comfortably in not knowing while remaining fully engaged with the process of discovery. It's not passive ignorance, but active appreciation for the inexhaustible depth of existence. As you breathe with this recognition, take a moment to notice how your own relationship with uncertainty might have shifted during our time together. Are there questions that feel less urgent to answer, mysteries that feel more beautiful to contemplate, aspects of your own experience that you can appreciate without needing to fully understand? The universe, through 2024's uncomfortable revelations, seems to be offering a masterclass in what contemplative traditions call don't know mind, a quality of awareness that can remain open, curious, and responsive without the compulsive need to categorize every experience into familiar patterns. This don't know mind doesn't abandon critical thinking or careful observation. Instead, it holds these tools within a larger context of appreciation for the creative mystery that seems to be the deepest nature of existence itself. It allows us to be precise about what we can measure while remaining humble about what we cannot comprehend. Consider how this quality of consciousness might appear in your daily life. When you encounter a sunset that takes your breath away, you don't need to understand the physics of light scattering to appreciate its beauty. When you feel moved by music, you don't need to analyze acoustic frequencies to let the experience touch you. When you connect deeply with another person, you don't need to map the neurochemistry of empathy to value the relationship. the same appreciation can extend to cosmic mystery. We can be precise about measuring dark energy's evolution without needing to possess a complete theory of cosmic destiny. We can document quantum time paradoxes without needing to resolve them into classical logic. We can observe biological transparency without needing to eliminate the boundaries between visible and invisible. What emerges from this exploration is something we might call an ecology of wonder, a way of relating to existence that recognizes the interconnection between scientific precision and contemplative appreciation, between analytical rigor and intuitive wisdom, between the measurable and the mysterious. This ecology doesn't pit science against spirituality or reason against intuition. Instead, it recognizes these as complementary aspects of human consciousness, different instruments in an orchestra of inquiry that reveals its full beauty only when all the parts are playing together. The scientists who made 2024's discoveries weren't just analytical machines processing data. They were whole human beings capable of wonder, curiosity, and appreciation for beauty. Their willingness to be surprised, to have their assumptions challenged, to remain open to possibilities they hadn't previously imagined. These qualities of consciousness were as essential to their discoveries as their technical expertise. Dr. Albert Einstein, whose own discoveries emerged from a profound sense of cosmic wonder, once reflected, "The most beautiful thing we can experience is the mysterious. It is the source of all true art and all science. He to whom this emotion is a stranger, who can no longer pause to wonder and stand wrapped in awe, is as good as dead." As you sit with this recognition, take a moment to appreciate the mystery of your own consciousness, your own capacity for wonder, your own ability to be moved by ideas and possibilities that you may never fully understand. This capacity for wonder isn't separate from scientific discovery. It is the soil from which all genuine inquiry grows. The uncomfortable truths revealed by 2024's scientific investigations point toward a reality that is far stranger, far more creative, and far more responsive to conscious inquiry than our mechanistic worldview could accommodate. But perhaps the deepest truth isn't any specific finding about dark energy, quantum mechanics, or biological systems. Perhaps it's the recognition that reality itself seems designed to exceed our expectations, to surprise us with new possibilities, to invite us into ever deeper participation in the ongoing creativity of existence. This ongoing creativity includes your own consciousness, your own capacity for wonder, your own ability to hold uncertainty with grace while remaining passionately engaged with the mystery of being alive. Take a final breath with me and let yourself rest in this profound recognition. The universe doesn't just contain mysteries, it seems to be made of mystery itself, woven from questions that generate more questions, built on foundations that shift and transform the moment we think we've understood them. In 2024, when we asked the cosmos our most sophisticated questions, it answered with dark energy that evolves, with time that flows backward, with matter that exists in impossible states, with biological boundaries that dissolve before our eyes. These weren't the comfortable confirmations we hoped for, but invitations to expand beyond our current limitations and embrace forms of understanding that honour both scientific precision and the irreducible wonder of conscious existence. Perhaps that's the deepest teaching of all, that our discomfort in the face of cosmic truth isn't a sign of failure, but evidence that we're growing into forms of consciousness capable of participating in realities far stranger and more beautiful than we ever dared imagine. The universe, it seems, has been waiting for us to develop instruments sophisticated enough to hear its most profound secret. That mystery isn't the absence of knowledge, but the presence of infinite possibility. Thank you for joining me on this journey into the uncomfortable beauty of cosmic truth. Until next time, may your questions be as vast as the universe itself, and may your wonder never cease to grow. May your wonder never cease to grow.